differentiation, but this time we're going to find the second derivative, okay? So let's start. We're going to take the derivative from left to right. The derivative of 2x cubed is 6x squared minus the derivative of 3y squared is 6y times dy dx, or y prime, is equal to the derivative of 8 is 0. Okay, so we're going to solve for y prime, and we've got just one y prime there. So we're going to solve for that, and we're going to subtract 6x squared from both sides, and we get a negative 6y y prime is equal to a negative 6x squared, because we subtracted 6x squared from both sides. And now we're going to divide both sides by negative 6y, and we get y prime is equal to a negative 6x squared divided by a negative 6y, and of course this simplifies to x squared over y. And so let me write this down here. This means that y prime is equal to x squared over y. Let me cut that and move it down here and continue to work down. Alright, so I'm going to put a circle around this. This is sort of an intermediate solution. This gives us what y prime is. But we're not specifically looking for y prime. We do need to get it. We're looking for y double prime. So what we now have to do is take the derivative from left to right of this equation. Okay? So I'm going to work up top here. What we have is we have y prime is equal to x squared over y squared, over y, and we're going to take the derivative of both the left and the right hand side. So we're going to take the derivative with respect to x of the left hand side, move this over, times the derivative with, let me move this over a little bit, the derivative with respect to x of the right hand side. Okay, so the derivative of y prime with respect to x is y double prime. I'm going left to right. And now what I'm going to have to do is I'm going to have to take the derivative of x squared over y with respect to x, which means I'm going to need to use the quotient rule. Okay? So let's do that. So I'm going to have a quotient. Remember, it's low, which is y, d high, so that's a 2x, minus high, which is x squared, d low, which is going to be y prime, over y squared, right? So what I did is I have the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. All right, so I'm not done yet, because what I've got to do now is, hoping that you can see here that I actually have a y prime within the expression for my y. Exactly. So we're going to have to substitute in y prime right there. And so we're going to get y double prime is equal to, well, the first term is 2xy minus x squared times y prime, which is x squared over y. And all of this is divided by y squared. That is divided by y squared. And of course, a better way to write that is multiply by the reciprocal, right? So what I really should do here is make this multiply by 1 over y squared. Okay, that's the divide by y squared right there. So, this is y double prime. So that means that y double prime is equal to 2xy minus x to the fourth over y. And of course, this is multiplied by 1 over y squared, so we're just going to distribute the 1 over y squared. So the first term is going to be 2xy over y squared minus x to the fourth over y cubed. And certainly this can be simplified so that y prime, double prime, is equal to 2x over y minus x to the fourth over y cubed. And I'm going to put a box around this. This is our final answer.